Bismillahirrahmanirrahim. Welcome to the new lecture of physics. So today we are going to study about electric field intensity, and electric potential difference. So the first thing which we need to be study is called electric field. So electric is, if you can pronounce the word electric, elect start from electron, and you know about the field. Okay, so a field around a electron, this is your field, let's see, and this is your electron. So we can say that the field around a electron, or we can say, because we have a two type of charges, electron or proton, or we can say positive and negative. So the field around a charge is called electric field, which is the simplest definition. So coming to the definition, that the field around a static charge. What is electric field? A field around a static charge or a rest charge is called electric field. Let's see. We have one thing you need to be keep in mind about positive charge and negative charge. Okay, positive charge is always transmitting the rays. Okay, and negative charge is always absorbing, attract the rays. Okay, so keep in mind these two concepts. So let's see, we have a positive charge. So positive charge is always going to be transmit the rays. Okay, so if you have a positive charge, and this positive charge is going to be transmitting, it's going to be transmitting. Once if this will be negative, let's see, once this will be negative, so it will be attract or absorb the charges, that will be in this direction. So this is the concept behind the positive and negative charge. Okay, so we can also be examined like that. It's just like example of gravitational field as well. If you know about a gravitational field, so what gravitational field can do? Gravitational field can attract all the object in the surrounding to itself. So you can see this is your gravitational field. Everything in the universe is attracted by a gravity. So the electric field is just like a gravitational field as well. Okay, so another definition for electric field, we can say it, the field where the other static charges can feel the electric force. So one thing you need to be keep in mind, in electrostatic, we have electric field. So in electrostatic, in a Coulomb law, in electric field, we always mention the static charge, because study of electrostatic is the charge will be in a static form. Okay, so keep in mind. So he's saying that the field where the other static charge can feel electric force. How is it? Let's see. This is your positive charge, and this is going to be transmit the rays. Let's see, there's other charges. Okay, let's see, there is some other charges which in the rest form, which is static, and these charges or experience this force which is emitted by a positive charge. So once these static charges can feel the electric force, what is electric force? A force which is experienced by a charge. This is electric force. Now a positive electric force. So when these charges or experience the electric force, so this is called electric field. So now coming to the space around a charge. So the same concept will be here now. Once we have a positive charges, so what can do positive charge? Positive charge can emit the field line. So this is your positive line. So this is called field lines. So we have a negative charge. What can it do? It can absorb all the charges, all the field lines. So the electric field from an isolated positive charge, the electric field from an isolated negative charge. So coming to the electric field lines, let's see. We have a positive charge. Okay, this is a positive charge, and positive charge is always going to transmit the field lines. We have a negative charge. What it can do, it can absorb the field line. So the positive charge is transmitting, this is the positive charge is going to be transmit the field lines. Okay, and we have a negative charge in this field, we have a negative charge in this field. So what it can do, it will absorb these field line which is emitted from a positive charge. So this negative charge will absorb all these field line which is in the direction of negative charge. So this is the way how electric field line can emit, how electric field can transfer, how electric field line can be absorbed. So this is the basically relationship of positive and negative charge, and you know about a positive and negative charge, that positive and negative charge can attract each other. So this is the concept behind the attraction of positive wave, negative charges. Okay, so now coming to some basic concept, so you guys need to be keep in mind forever. So the conductor and electric field, conductors and electric field relation. So like under electrostatic condition, this is more important, you need to be keep in mind in electrostatic condition. So the electric field is zero, the electric field is zero inside a charge conductor. Let's see, this is your charge conductor, is like, so the electric field will always be zero inside a charge conductor. Inside a charge conductor will be zero. So electric field is represented by E, and electric field is a vector quantity, so it is what we, and electric field inside a conductor will always be zero, because when we have a charge on a conductor, so the charge will be on the surface on here. Okay, so and this charge is going to be emit or absorbed. So the inside a conductor, the electric field and zero will be zero, and on the surface of a conductor there will be a electric field. Okay, so the second is axis charge on an isolated conductor reside on the surface. As I tell you, axis charge will reside on the surface of a conductor. Okay, the third is axis charge accumulates on a sharp point. Accumulate on a sharp point, it will be accumulate on a sharp point. The number fourth is electric field line meet the conductor. This is your electric field line, it can be emit, it can be absorbed, so it will be meet the conductor perpendicular the surface of the conductor. How it can be, let's see, this is your surface. Okay, electric field is that taking on the surface, or electric field is going, so that will always be perpendicular. Perpendicular means it will make angle of 90 with the surface of conductor. Okay, so the shielding effect, once we have a shield is just like a protection. Keep in mind, shield is just like a protection. So due to shielding effect, the electric field is zero inside a charged conductor. So this and this both are the same thing. Why the electric field inside a conductor is zero? It's because of shielding effect. We can say it shielding effect. So now coming to the electric field intensity. So hope you guys know about intensity. Intensity is just like a force, how much the force is applied on an object. So this is called intensity. It's just like a power. So electric field intensity, the definition of electric field intensity, which is so simple, from a formula you can learn it, so forever it will be in your mind. So he's saying that the force or we can say the electric force can experience by unit positive test charge. Unit positive test charge means it will be 1. Unit mean 1. Okay, so the force experienced by positive unit test charge is called electric field intensity. Okay, so keep in mind, electric field intensity is a vector quantity. Okay, which is denoted by E. So the electric field E at a given point, so the electric field E is the force per unit charge that would be experienced by a test charge at a z point. So this force, once we have this force, it means we will have some other charges as well. So we have a charges here, let's see. So due to these charges we have a kind of a force, and this force will be experienced by this charge. When the force is experienced by a charge, so we can say this is called electric field intensity. Okay, so this is a vector function of a position. So how we can define, we will have a moment arm and we have a force. So the test charge will experience the force because we have a, if you can remember, the distance between two charges. So later on in the Coulomb law, so this is the R between the distance between two charges. Okay, so now coming to just simple thing, group of fixed charges, we will have a group of fixed charge, like if we have a two charges, 3, 4, 5, so more than one charge we have for a Coulomb law. So exert a force F given by a Coulomb law on a test charge Q, okay, at a position R. So this test charge is at the position R, and the force and the Coulomb force F is applied or experienced by a Q test charge. So coming to the proof of electric field intensity now by Coulomb law. So as we know that about a Coulomb law is always equal to, we have this kind of formula, F is equal to K Q1 Q2 divided by R square. So if you want to write Coulomb force in term of vector form, in term of unit vector form, so just write down a unit vector here. So the momentum, the distance is the unit vector. So this unit vector is because of representation of a vector form. Okay, so if you don't write it, so it doesn't matter, but if you write it, it will be good. So this is your Coulomb law. So in a Coulomb law we have two charges. So the force which is experienced by a Q test charge, so it means we have a Q, this is your Q, and the Q2 is your test charge. So because you know about the Coulomb law, Coulomb force which is between two charges, so that's why we have a Q and Q test. So we have a two charges and it's over Coulomb law, and K is always equal to 1 divided by 4 pi epsilon naught, and epsilon naught is the permittivity of a medium. Okay, so this is your Coulomb law. Okay, so now what we can do, we will put this force in a electric field intensity formula. Okay, so both are a vector. So this is our Q test. So put in this formula. Once we put it in this formula, so this Q test and Q test will be cut out. So our result will be this one. So this is our electric field intensity formula. So electric field intensity is equal to 1 divided by 4 pi epsilon naught Q divided by R square with the unit vector. So you can be write down, instead of this is K. Okay, and you know about the K will be 9 multiplied 10 to the power 9. Okay, and so on. So radially outward falling alpha 1 divided by R square is alpha distance of a charges. Okay, this was the basically the concept behind the electric field intensity, and the electric field intensity for a unit positive charge is this one. Okay, hope you guys got the point about the electric field intensity. So now coming to the electric field. So if you can see in the figure A, we have a positive charge, so the electric field will be in this direction, and if once we have a negative charge, so electric field will be in this direction. So if you can see the strength of electric field, so you have a positive charge here, so a charge is in the 8 point A, so the field, the force will be in this direction, the force 8 point B will be in the this direction. Okay, if it will be C, so it will be C and D and so on. Okay, so the third is superposition of electric field. Superposition means just like adding two things, but not like the same of adding, but just for the concept is just like addition. Let's see, we have a two charges Q1 and Q2. Q1 have a electric field and Q2 have a electric field. So from a Q1 we will take the point here, then from Q2 we will have a take a point here. So extend this one into this direction and extend this one into in this direction. So at this point just think like that it going to intersect each other. So one thing you need to always keep in mind that vector will not intersect each other. Well, vectors will not intersect because vector have a single direction. Once a vector is going to intersect each other, so it will have a two direction. Okay, but it's just about the superposition theorem. So in this case, so we will extend it out. So here we will have a electric field E1 due to Q1 charge, and we have electric field E2 due to Q2 charge. So this is basically because of superposition theorem. So now coming to the electric field lines. So electric field lines, if you can see, the electric field line are continuous lines because continuously it is going to emit or absorb by positive or negative charges, so whose direction is everywhere that of the electric field. This is your positive charge and your direction is everywhere. It's your electric field line. It's a negative charge and the direction will be in anywhere, but it's going to be absorbed. So some basic characteristics of electric field lines: point in the direction of electric field. So point in the direction of electric field, start at positive charges or at infinity, because positive charge is going to be emit the field line. So when it's going to be emit a line, so we can say it will be at infinity. And at negative charges are at infinity. And mean, so it is starting and it is ending. It's going to emit, it's going to be absorbed. So this is your start point, this is your end point. So or more denser where the electric field has a greater magnitude. So what it mean? When we have a strong electric field at a point, when we have a strong electric field at a point, so we can say that electric field is more denser at this point because of the magnitude of electric field is greater than is too denser or is too much. So electric field is too much here, so it means the electric field will be denser at this point. Okay, so this is some electric field line characteristic. So now you can see in this example, like we have a positive charge and negative charge. So positive charge is going to be start and negative is going to be end, if you can see there. So it's going to be start, it's going to be end. And figure B, if you can see, we have a 2Q and single Q. So at this point, let's see, we can say at this point our electric field is more denser because there is two charges. There was one, there is two charges. When the charge is going to be increased, mean electric field is going to be increased. So at this point the electric field is denser, so it's going to be transmit and it's going to be absorbed. Then once we have in figure C, we have both positive charges. We have a same charges. Once we have a same charges, so same charges always to be repel each other. So if you can see, it's going to here, it's coming to here. Once he said that both are positive, so both are going to be repel each other. So when it's repel each other, so its direction is going to be in this way. So this is the electric field line characteristic. So coming to electric field line or a point charge. So we have a point charges. So this is about electric field, which is in a vector form and it's everywhere, and it's your field line which is mentioned in this type. Okay, so we can say that electric field lines are continuous lines whose direction is everywhere of the electric field, as you can see in the figure as well. So coming to the another topic, which is about force due to an electric field. It means the force, this force due to electric field now. Okay, so let's see, we have a positive charge. Let's see, this charge is having a field, electric field. Okay, and then we have a charge Q. Okay, so this charge have electric field okay, our electric field intensity. So once this charge is feeling or experience the force due to this charge, so this is called force due to electric field. What we can say, let's see. As we know about electric field intensity, which is like this one, the formula was this one. So now how we can write? We just write that force will be on the same and Q will come to here. So the force due to electric field and Q will be here. So this charge is going to experience a force from this charge due to electric field. So you can say, just run the definition of electric field around. If electric field is noun, the force F on the charge Q at a point R is, so this will be a definition. So the electric field at R point in the direction that a positive charge placed at R would be a positive. It means so the direction will be in this way. So electric field lines are bunched closer where the field is stronger. So you know, when we have more charges, so the field will be stronger there, and will be have a bunch of lines. I mean, there will be a group of lines. When the electric field line is more, it means the electric field is stronger. Okay, so this was about force due to electric field charge. So I'm just explaining this very simple way, in a very short way. Hope it will help to you. So just try to learn it. So this was your lecture for today. So hope this lecture will help you. So try to watch it out. Once you have any question, so mention in the comments, so I will be happy to be answer to you. So thank you for your time. See you in the next lecture.